In a fast-paced tech environment, the potential attack surface increases with each release and new app created. Detectify automates cutting-edge knowledge from trusted ethical hackers into the development pipeline for reliable application security. Go beyond the OWASP Top 10. Check your web apps for over 2,000 known vulnerabilities actively exploited in the wild, monitor subdomains for potential takeovers, and remediate security issues in staging and production. Learn more with a free trial at securityweekly.com/Detectify. Go hack yourself. Cloud native development presents new challenges for security teams. Ephemeral workloads are scattered across services, and it's hard to identify resources, monitor configurations, and ensure compliance. Prisma Cloud by Palo Alto Networks is a comprehensive cloud-native security platform, delivering full-stack protection for multi- and hybrid cloud environments. It provides deep visibility, threat detection, and data security, as well as protection for hosts, containers, and serverless while enforcing policy guardrails. Visit securityweekly.com/Prisma Cloud to gain control over your cloud security. We're proud to announce CISO Stories, a new podcast series in partnership with Cybersecurity Collaborative and Cybereason. CISO Stories features the candid perspectives and experiences of frontline senior security executives and dives deep into timely security topics. CISO Stories is hosted by Todd Fitzgerald, VP of Cybersecurity Strategy at Cybersecurity Collaborative, and Sam Curry, Chief Product and Security Officer at Cybereason. Listen weekly as they speak with extraordinary CISOs by visiting securityweekly.com/CSP.
I don't care if Monday's blue because I'm back here with all of you on Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Do you want to stay in the loop on all things Security Weekly? Well, you can visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. You can sign up for our mailing list and you can join our Discord server. Do you have a specific guest or a topic that you want us to cover on one of the shows? Submit your suggestions for guests by completing the form at securityweekly.com/guests. We review suggestions monthly and we'll reach out to you once reviewed. John, we're back to the news. And riffing on The Cure, it took 40 years for them to get inducted into the Rock and Roll Hall of Fame. So that was only 2019 they finally made it into there. And speaking of long durations, there was some, this is how we do segues now. There was a Linux kernel vuln, or some vulns in Linux kernel that had stuck around for about 15 years before being discovered and revealed. And there's a couple different paths we could take this. And in fact, I didn't think it was really worthwhile too much, at least for me, to go down the path of, everybody missed this. How hard is it to grep for sprintf? And maybe more about the angle of, is possibly so many low-level vulns or unknown impact vulns or perhaps cruft in the Linux kernel that how do you approach prioritizing fixing vulnerabilities? Or even, I should say, how do you prioritize fixing potential bugs? And I'm just going to leave that as sort of the rhetorical question for our listeners, unless you want to try and take a stab at that.
Yeah. First, I'm not sure, do I feel older because it took so long for The Cure to get in, or because this bug's been here for so long? I was going to try and take a stab at rephrasing your question a little bit further again. Is the priority on fixing the bugs, or on putting a priority into saying we're actually going to try and find these issues? So I guess I'm not sure if I'm being too finicky with the wording there, but yeah, I mean, this is SCSI. I mean, I don't know if any device I have, I don't think any computer I have right now has a SCSI device on it. I think I can say that. And again, this is all home stuff, right? And we've had SCSI at home in ages, and that's probably part of the reason. And even the cloud guys are all using custom motherboards that don't have SCSI on them. They're using FCAL and stuff like that, if anything. So I can see why it's been sort of sitting to the side. Like, even if you have this exploit, who do you exploit this on? Or who do you leverage this exploit for? But still, yeah, how do you, if your company is working on open source, right, you're usually trying to, a lot of us who are doing this, we're trying to get new functionality in there to better our products one way or another, but at the same time, we want to contribute back to the community. How do you carve out budget, which is really what it is? So good time for Matt to come in, but how do you carve out budget to actually say, we're going to take a week and go back through the code and see if we find things, And then finding's easy, right? Like, how do you actually track down and fix it? So, I don't know.
Yeah, I think that's a great point. 20% rule, because and even too, in the spirit of even extending and rephrasing these points, one of the things too, you made a great point, like looking around your room. Did you even have any SCSI devices? But this would be more of, do we fix it, or can we just reduce our attack surface by getting rid of code? Now, I will acknowledge very quickly, open source like this, they do want to have a certain population and support for all kinds of weird and esoteric and even perhaps legacy types of hardware. But if you take this too far, you get into sort of that OpenSSL situation where you're like, well, we have all of this weird custom crafted shell code and assembly that's for these particular obscure architectures that as an open source project we want to support, but the weight of that means it's a lot harder to introduce a lot more modern compiler settings, a lot more modern just software design. So this would be a case where I'd kind of just highlight, you have some old code in here. It's potentially exploitable, possibly not reliably exploitable, but the great point is, who do you attack here? And so should we bother fixing it? Can we also just rip it out and reduce our attack surface? And I think those are some lessons, some conversations that security and DevOps teams could have pretty much anywhere, because I'm pretty sure this type of situation, even 15-year-old code, even 10-year-old code, you're going to be able to have these conversations.
And you're spot on there. So first, one of our listeners pointed out to me that this is iSCSI as well as SCSI. So thanks for a correction on that. So there is some chance in there. But you just asked a standard hardening question, right? Like if you're running, and we've talked about this in the past, I think at least one issue Amazon's had over the years was with the floppy driver or USB driver. So there's still a chance of this stuff coming in and biting you. But if you're building a custom kernel, if you don't need SCSI, turn that. And iSCSI, I could see possibly people trying to mount into EC2 or Azure. So maybe there's a use case there, but but still harden if you can.
Harden if you can. And speaking of harden if you can, of course, I think I'm possibly repeating this too many times, but SolarWinds put supply chain on 2021, even though supply chain goes back pretty far. There's two articles here that are kind of related on different ways of targeting supply chain. One is Azure SDK. That was kind of an interesting vulnerability or an interesting demonstration that wasn't exactly dependency confusion nor typo squatting, but just another clever way to kind of poke a little bit to see how packages are brought together by trusted organizations. So there's a bit of trusting, who do you trust here? This was an article you saw. So tell us a bit more about this.
I think this is, I like the way you phrase that there. I think this is something we're going to be seeing. I think I probably said this before, but over the next year or so, where we're finding the issues right now, it's not the code. Well, it's not in the application source code. It's in the code around it, which is actually the build code, right? How do we put this stuff together? And you were just talking about, do we want to go and update our build flags, right? That's what my comments go to say back there. I forgot was, I have no idea what the unit tests are like on a Linux kernel. I have no idea what type of test coverage they've got there. But if it's not great, you're not going to go and start screwing with something just cause. And this is sort of an example of that again, is long story short, what's going on here is the guys who did this, the plugin itself, they want to be able to, have it loosely coupled, which sounds like a great idea and usually is. But the idea is if someone else had tagged their code as, and I'm forgetting the exact words, I'm going loosely, it's loosely sort of part of the main Azure SDK, then let's gather those components together, if it's a component of, gather those components together and then display it in the download page. And what someone figured out there with a little bit of trial and error was that they were able to voluntarily say, hey, I'm a component of that, and got themselves listed on that download page. And probably wasn't there very long, but it's definitely that cat and mouse thing which we're used to in security. How do you okay, you're signing your code, okay, great. Now how else can I get my stuff in there? Do I have to go early in the process and compromise the developer? Do I have to go later in the process, compromise the download server? Hey, how about this thing in the middle here? I can just get where you're bringing these pieces together to display, and I'll put something in there. So Interesting find, a little bit creative.
A little bit creative. And, speaking of also too, which direction do you go to try to compromise the supply chain? In the direction of let's compromise the developer, I threw another article just about malware inside of Xcode. And again, I don't know that there's, this wasn't particularly exciting, particularly novel to it. I did appreciate that it's basically a one-line change. So it shows how simple this backdoor could be. But I also kind of wanted to link to a very old, famous article in InfoSec from Ken Thompson about basically backdoors. And this was from, in the spirit of not just pointing out, everything old is new again, or everything new is old again, eventually will come full circle, but just sort of is trying to build up the sense of the idea of backdooring GCC, or backdooring your compiler, and then your compiler builds your trusted software, but the untrusted compiler puts in some untrusted code into your trusted software that you've signed and you've put onto SigStore, etc. It kind of breaks that particular model. And so these are threats. These are types of attacks that have been reasoned about. They're not necessarily new. So more highlighting it in the sense of let's remember them and let's keep those in mind as we are building these types of hardening throughout the supply chain to make sure that while we fix one area, we can get that turtles all the way down, to use that cliche. And I try to avoid cliches as much as possible, so sorry about that one. But just that spirit of, even call back to our previous segment, there's a lot of vulnerabilities that keep getting reintroduced, and if we have a better memory within the application security industry, perhaps we can work better on fighting back and pushing back on those, and detecting and minimizing the impact when they crop up again, which I think is possibly the case in this situation.
Yeah. I'm going to try and stay positive on that one, not go negative. I missed your link to the Ken Thompson article, so I was taking a quick peek at that. God, is that 30 years? 1984. Some do math. But yeah, that's it's, as you said, this isn't something new. It's we're getting new attention on it now as we're going cloud native, and we're getting used to using all these puzzle pieces. I had made a comment on Discord in the previous segment that the security industry is sort of a bit of a got a regression itself, right? In that we keep going back and doing that same thing again. It's another. I think the reason we're pointing these out is we're trying to educate people and sort of show what's going on out there, and it's not just you in your own little world. And these are examples of things to look for in your own code, right? It's what does your build process look like? Or if you don't have access to it, go and ask the guys who are running it, like how does this get built? Are you using something that's in our makefile that we can look at? Or is there something in some completely separate repo that you don't have access to? And how does that work? Are you signing code? Where are the keys kept? So that's really why we keep bringing these things up, is hopefully give you guys something to think about.
Yeah, and it's very much in the sense of trying to educate the how to think approach, in the sense of, okay, just imagine that you have your endpoint is compromised, or someone downloads a freemium software. What does your endpoint security look like, both in terms of detecting it, how badly, do you have a multi-approval process in your code, for merge, approving merges? Are there other, basically getting to the idea of how many process tools are in place that would mitigate the potential impact of this type of thing, that would prevent the next SolarWinds, dun dun dun, which I say with a little bit of a wry irony, and try not to overstate the case there. But let's switch from the ancient past into the modern GCP 2020, and here's another article that I linked to, again on that spirit of education. So it doesn't matter well, it probably matters quite a bit if you're running GCP. These are more relevant to you because a lot of these articles, there's 6 vulnerabilities that were listed here that overall just were over $300,000 worth of rewards, which are fantastic work for all of the researchers there. And what's nice about the write-ups is that there's a combination of here is what this particular part of the tech stack within GCP does. So it's just a really nice put into context. What does OS login do? What does containers look like within this particular aspect of GCP? So just a good education from that perspective. And a couple of them, especially just the first one, the RCE in the cloud, it's just a really nice write-up about the thought process that goes into the discovery and analysis of a vulnerability. The other one about SSRF also goes into a relatively simple, straightforward SSF vuln, but goes on to a tangent of how do you, of demonstrating a particular vuln that seems at first sort of a blind exploitation, meaning you're getting back a 200 response code and that's about it, actually gets turned into leaking an access token, so much more consequential. So I think those, in terms just kind of an educational perspective, I think they're pretty neat to read through just to think about that attacker's viewpoint.
Yeah, I just got sucked into one. I hadn't looked at all the details. There's one down there around gvisor, and also another around container drip. So gvisor is one of those things I've been looking for an excuse to look at closer. I think I ran it briefly when it came out, but it looks like, just scanning this quickly, it looks like the vulnerability wasn't in gvisor itself, but in the metadata around it. And again, coming back to what we're saying, right? It's as we are making improvements in AppSec, believe it or not, and as we do that, people have to go and look for some of these other ways around to get in. But yeah, there's a bunch of good write-ups here.
Bunch of good write-ups, and which was the write-up? There's the write-up about lateral movement and privilege escalation. One of the things that kind of stood out to me for that one too, it's a good example of just one particular insight into the product management, if you will, or imagining what does it look like from the outside to fix a vulnerability that's been reported. And this was pretty interesting read just from that sense of getting an appreciation of how does product management respond to a security vulnerability in terms of, is this a vuln? Do we have to fix it? Well, what's the real feature here that's broken? And it did, get to the point where Google did get a little bit of a fire lit under them by the 90-day disclosure process. So, as much as Project Zero is really good about pushing that to others, it was good to see that Google responded to that 90-day type of constraint as well.
Eat too, brute.
Exactly. Callbacks to the last episode. Speaking of not callbacks to the last episode, but something that is also perhaps new and different, and still on a sort of supply chain, I want to say. A neat article from Vice talking about a hacker got all my information for $16 because they hacked SMS. And now I don't want to overstate the case here. This is the type of vulnerability that doesn't necessarily scale very well, but it can be really impactful for those of you who are targeted. So important there. But in this case, what at least stood out to me was that this was an SMS attack that wasn't part of an SS7 protocol weakness, because I think for the longest time, SS7 is just known to be a horrible agglomeration of protocols that sort of forgot to put any type of security in terms of authentication, authorization into them, and hence lots of problems. And it's not just a pure social engineering like we saw with the Twitter attack from last year, 2 years ago. It's just a sense of, hey, I've changed my number, or I need a password reset, please. This was more of something that's kind of out of your control in the sense of, did you even know that there are these trust relationships within companies within the SMS supply chain that could be abused to basically say, hey, I would like to get Mr. John Kinsella's SMS forwarded to this number, then I'll forward it to another. And no, I don't have any, ID to prove that I am Mr. John Kinsella. Will you do this for me? And the company basically says, we trust you. We've heard you on ASW. Your voice sounds about right. Sure, we'll do it. I think that's what this vulnerability kind of boils down to. It's just one of those surprising aspects that there are more suppliers within a platform that perhaps are understood at the time.
Yeah, so it's sort of in a way a network attack or on the network infrastructure. So the way I'm saying it that way, long story short, SMS, the way the phone system works, it's a little bit like routing, TCP routing from a level of you have a routing table. And what these guys figured out that there's companies out there that have sort of legitimate reasons for that, right? But as a network administrator or as a sort of a WAN admin, if you're going to bring your fiber or a new connection into a data center, bring it to Google or whatever else, you usually have to have what's called an LOA, letter of authorization, that, yes, this connection should be made from this guy to this guy. So it's a little more than Mike's voice on the radio, but not much. But what these guys have managed to do is they've got pretty much a wild card LOA that's, look, we're this business week, and I know exactly how this argument went, right? They had a meeting, or probably about 20 meetings, going, look, we can't be calling you guys every time with a new LOA. We can go ahead and do that, but you guys are, we're going to be killing you and stressing you. So, we built this relationship, you trust us. So how about we just have like a blanket LOA that we get from everyone for one time for all these phone numbers? And, obviously it's just being used for marketing. It's not that big a deal. So that's how this whole thing probably got set up. And now this, again, a creative person came along and found another use for it. When I saw this last week, one of the thoughts in my mind is, okay, I've got the other physical factor things of one form or another, and I'd already been trusting phone numbers or being, how will I say, less enthusiastic when I see a website or an application or something saying, give me your phone number for 2FA. And now, obviously, you're even that much less. So it'll be interesting now to see how long of that long tail do we have of companies that won't go and adopt a newer, better technology and are still going to try and do 2FA SMS for 2FA.
Yeah, it's definitely sort of the baseline. The table stakes should really be just the authenticator app, OTP, and ideally getting to the FIDO type of hardware token, WebAuthn type of crypto-backed authentication that not only authenticates the user, but authenticates who you're sending your credentials to. So getting rid of a lot of intermediation, a lot of impersonation attacks as well. But that was a great explanation, John. So I think what we might have to do is open up a social engineering live segment sometime in the future, and we just have you call someone up and see what can happen. These sort of things are similar to, in spirit, to sort of the long lack of strong trust relationships or confidence between them in BGP. So I think in the spirit of sort of trying to draw large parallels between $16 and attacking SMS, there's been some BGP hijacking that's just due to similar types of exploiting the lack of strong identity between who do we trust. And in terms of strong identity and who do we trust, in the sense of who's showing up to make some commits in my github.com, GitHub posted a really neat postmortem in the spirit of transparency about, as they'd say, how we found and fixed a rare race condition in our session handling. This is really neat, just in the spirit of, one, it's nice to see companies being more transparent. Now I'm repeating myself, apologize, about vulnerabilities that happen within their system. But this is also a pretty consequential one, in the sense that what would be a pre-mortem that you as listeners might go through in a similar situation, in the sense that GitHub went and logged out every single user of their platform because they observed a situation that said, oh, someone who's logged in as user A might just refresh their browser and see all of the information and be authenticated as user B. Not a good thing. So sort of those pre-mortem kind of seed questions I would set up there are, what type of observability would you be able to have? How quickly and with confidence would you have been able to dive into a similar situation in your own logs within your application? And what would be and who would be, in that decision-making process to be able to respond in this type of thing? So sort of just getting the sense of what's the maturity of your product security incident response team, your PSERT processes that you might have to respond to something like this.
Okay, wrong button, that button, mute. We've talked about this, we've handed it out a few times, and I know hopefully we'll change a few more minds as we say this, but usually people will take heart to what you just said, Mike, in an issue like this after they've had an issue themselves, unfortunately. But really, please, you're not just logging for the hell of it in your things, or so logging I'm always harassing people about, but also, okay, if we have an issue in, now, how do you roll back to your previous version? Is that going to happen, or is your database migrations one way, or do you have your old keys you can roll back to, or did you just delete them automatically? There's so many, we talked on here before about doing sort of tabletop examples for threat modeling and things like that, but also be able to do that tabletop experiment for rolling back is super important.
Yeah, and I think
it's incident response, not just rolling back. But yeah, go ahead.
Yes. Yeah, no, and the point is well made that, it's a little bit lazy if we just say, make sure you have logging and observability for your application, and we just kind of end the conversation there. This is a good example of what types of things should you have some logging available for, meaning could you track down that sessions are being incorrectly shared across 2 different IP addresses? How easily could you do that? And could you do that in a way that you're actually not logging all of your session tokens to some log file that's actually world readable to all of your engineers? Because suddenly now you've also introduced quite by accident, yet a new vulnerability within your system, even though you're trying to do something good. So I think there's a lot of interesting angles that hopefully could be taken in the spirit of what if this happened to us type of scenario, tabletop exercise.
And then one more thing before I forget, I need to sort of give props for the level of transparency in this article. It's not very many people are willing to admit in public in 2021 that they're using Ruby applications. So, props to GitHub for being transparent about that.
A slight pause as I think of how far I want to go down that route. Instead, I'm going to redirect our attention to some educational resources. So one of the things I've been trying to do too is find and highlight some educational resources that are either a list of 6 or so GCP ways of attacking GCP. These are kind of targeted towards container and GCP centric. But here's another article that I have to admit was brought to my attention from the TLDR-Sec newsletter, Hacking the Cloud. And a great resource, I think, that's focused on general knowledge about that's most salient to sort of a penetration testing aspect for cloud service providers. In terms of, I want to try to target it, how do I enumerate the resources that are out there? What are some common exploit scenarios? And then what's a little bit interesting here, maybe a lot interesting, depending on your perspective, is this hacking the cloud information is also organized into avoiding detection and post-exploitation. And now, one of the things that comes to mind there goes back to what we were just talking about is logging, in terms of how good is your logging that the avoid detection aspects of this hacking the cloud resource becomes a lot harder for the penetration testers, as well as the post-exploitation. So would you detect them in a matter of minutes, hours, days, or not until they show up with a, hey, by the way, here's the pen test report 2 weeks later? So again, I think possibly some good resources and exercises to go through in terms of how well configured do you think your cloud environment is?
Yeah, it's there's some neat stuff in here. It's not just, it's good to sort of go through and click around and read on some of these things, even if you think you know cloud. One just caught me. I haven't seen before. I just didn't know. They've got a breakdown of when you're looking at Amazon IAM identifiers. So it turns out there's the prefix actually is denoting what they are, and I didn't know that, but hey, cool. So yeah, these things are, if for our younger or more junior guys in the audience, this is great to study and sort of get a really good sense from one place without having to go and dig around and figure out, where can I Google for enumeration, or what's the right phrase to be Googling for to say I want to break into something, or practice my skills. But then on the other side, it's even for the more sophisticated folks out there who've been doing this for years and years, grab a tasty beverage on your favorite day of the week. And when you've got some time, and just sort of go through here, and if nothing else, it's like a refresher. So there's some good stuff in here.
Yeah, good stuff in there. And I know there's a great, there's a quite robust cheat sheet series from OWASP project. And that series, as well as this, they're both GitHub projects. So you can embrace, extend, add to them as well. So if there's certain things that you have in your own environments, or tricks of the trade of your own that you prefer, that you'd like to share with others, by all means, contribute to those types of projects. As well as you have other projects, let us know. We'd love to highlight some more educational resources. And so there, I'm starting to wind down to a grinding halt myself. John, any final parting words? Any additional thoughts you want to help us wrap up with?
Oh no! Don't give up now. Any parting thoughts? The talks are CNCF. KubeCon Europe is coming up next month. There's a security day for folks who are interested in that type of thing. I'm doing a talk there. There's a bunch of folks doing some really great talks. What else is going on? Hopefully people are surviving and doing well, and staying healthy. And we've in the northern hemisphere, we've survived winter, so we're beginning to warm back up. And that's my happy thoughts for today. So hope everyone's able to keep going in the right direction. Do good things.
Do good things, and stay warm in the spring now in the Northern Hemisphere, and go check out John's presentation as well as the others. Those are some good resources. So thank you, John. Thanks everyone for listening. Thanks everyone for hanging out in the Discord with us as well. It's always fun. We'll say thank you once again. I like to repeat myself, apparently, this particular episode. We're going to see you next week and repeat ourselves once more on Application Security Weekly.